day, ladies and gentlemen, and welcome to the Make IT Dynamic webcast on SAN infrastructure, hosted by Manuel Langer. My name is Carolyn, and I'm the event manager today. During the presentation, your lines will remain on listen only. If you require assistance at any time, please key star then 0 on your telephone, and a coordinator will be happy to assist you. I'd like to advise all parties the conference is being recorded for replay purposes. And now I'd like to hand over to Kira Frey.
Well, good afternoon, everyone. My name is Kira Frey, and I'm a Program Marketing Manager at Fujitsu, and would like to welcome you all to this webcast on, which will provide you with an introduction to storage area networks. And with me today is my colleague Manuel Langer, who is a storage consultant as well here at Fujitsu, and he will guide you through this call in a second. And perhaps to just give you a short background around this webcast. So this basically is the kickoff for a series of technical webcasts we are offering you around different topics, and these different topics come out of our current channel initiative called Make IT Dynamic. And in this channel initiative, we are covering basically 4 topics. One of them is storage area networks. Then we have virtualization as a focus topic. We're looking at high availability and business continuity topics, and at backup. And as already mentioned, this webcast is the first webcast in a series of 4 webcasts, and the idea is to give you an understanding of these different topics we're talking about in Make IT Dynamics. So we are having this webcast now in July, and we'll follow up with 3 additional webcasts in September timeframe, for which you will hopefully then receive an invitation as well. So, I would now like to hand over to Manuel to guide you through this main topic of today's call, and Manuel.
Okay, thanks, Kira. As Kira said, I'm working for Fujitsu as a storage consultant in Germany, mainly in the competence center online storage. So my main focus area is online storage, but of course I have some good know-how in the related connectivity technologies also. So what I'm trying to do today is give you an overview of about storage area networks, give you some basics, and give you details about the concepts and features that are available with storage area networks and the connected storage arrays. I can tell you one thing: you will not be experts after having heard this webcast, but you will have a good understanding of what this is all about. Okay, this is a traditional layout most people will recognize. This is a grown environment with several servers connected to a front-end local area network servicing their clients. Each of these servers has its own local attached storage. These environments are, as I said, grown over the years and have a lot of challenges and problems to overcome. When trying to size these servers, you're encountering the problem that you have to calculate each server on its own. You have to calculate the needed capacity and the needed reserves, and you have to also calculate the data growth over the next 3 years. So when you're sizing these environments, basically you calculate the currently needed capacity for the server, add the data growth over 3 years, and the reserve, and you get a number of terabytes you need for this single server. If you have these calculations done, you buy the server, and it's a really static configuration in that way. If you try to overcome these challenges or problems, you have to take into account that all this storage topics is about capacity, reserves, and IOPS. IOPS is the main performance calculating number you have to look at if you're talking about storage systems. Storage IOPS is basically input and output operations that can be done by the storage array and that give you a number of how fast the storage is. With the traditional layout of directly attached storage or storage that is located inside the servers, you're usually sizing by capacity. As I said before, you're having a look at your application and how many disk space it needs, and therefore buying disks to get to this capacity. You're not sizing by IOPS. So you basically say, I need 10 terabytes, so you're going and buy 10 SATA drives to get these 10 terabytes. You end up with few large disks, and inside your server, the expandability, so the possibility to increase the capacity is very limited, because you're limited by the number of slots the server has. And with these problems given, you have, when sizing the environment, you normally have at the beginning way too much capacity and way too much reserves in each single server, but you end up with multiple servers having free space while single servers not having any free space because an application grew unplanned, and you do not have the reserves for this single application. But you're encountering the problem that you can't just go and share the capacity you have, because it is located in every single server, because through that direct attached storage. Capacity is one problem, performance is the other problem. You may have an application that grew a lot, but you're still having free capacity, but the response times and the throughput for this application is way too low. Again, you can't just take all your disks and add them to this application, because they are fixed in the server that we're talking about. If you size the other way around, so you're sizing by performance, you normally end up with far too many disks and far too much free space for the application you size for. So you're basically buying way too much disks. Another challenge and problems is backup, because in a traditional layout you are backing up every single server on its own. So you're using the client network basically to do backup for this server, and that's basically the only thing you can do, because you cannot take advantage of storage features that a centralized storage can offer you. To do these backups, you have to do carefully planning of your backup window, and have to make sure that you're not interrupting your clients during that backup operation. And it takes a long time to back up in most cases. If you want to do a hardware upgrade or a replacement or an update of the hardware the server has, you have the problems I mentioned before. You're limited by the physical resources the server can offer, so number of slots to add more disks, and it's usually connected with downtime, because you have to take down the application, do all the physical rebuilding things, and maybe change the server and then put everything together to boot it up. This usually are projects that take a long time and have to be carefully planned, so it's not easy to do an upgrade in this kind of environments. When it comes to storage management, it's obviously very, very difficult, because you're looking at several different servers, different types, different disk types maybe, and there's no unified management for these. You have to take a look at every single server and carefully watch the amount of space that is free and the performance of every single server. Okay, when talking about a storage area network, we're basically adding a second network to every server. Again, we have the front-end local area network, of course, because your clients will still have to connect to your servers. But we're adding another network in the back end for the servers to access a storage array that provides disks and capacity for all servers that are connected to this storage array. There are a lot of advantages in this scenario, because when planning these kind of environment, obviously you still have to calculate how many space you need, that's sure, but the next step is different, because you don't have to calculate the required space based on the next 3 years, because you want to avoid that the hardware has to change in the next 3 years, but you can calculate on, let's say, 1 year. Why is that? Because it's very easy to add additional disks to a centralized storage array online. So if you end up with having done a wrong calculation, it's no problem to add disks. The next thing, of course, a reserve is also recommended if you're using a storage area network with a centralized storage, but the percentage can be lower because you're sharing the reserve across all your attached servers. So if one application is growing unplanned very much, then it's not a big deal, because you're having a reserve for all your attached servers. So we're not talking about full capacity, but about startup capacity, because you plan to add more disks as soon as you need them, not having the whole number of disks when you buy the environment. Okay, there are several different ways to attach a storage to a server. We're talking about direct attached storage. That's if a local storage array is attached to a server. This may be internal disks connected to a RAID controller, or a external storage JBOD system that is only attached to the local server. We call that a DAS, direct attached storage. The second possibility to add storage is a network attached storage. That's also not the kind of storage area network we were talking about in this webcast. This would be a system where you have several servers that connect to a file server. What we're talking about today is a storage area network with a shared storage array that is block-based, and giving block-based LANs to each single server that can access the LAN and add his file system as he needs. So there are several benefits of a centrally managed storage area network, and with this storage area network, of course, with the storage that is connected. And the first benefit is, if you trying to add high availability to your servers, you have to make sure that the server that takes over the operation of your primary server, that this server has access to the data that your primary server uses, and you achieve that by connecting several servers to this centralized storage and sharing a volume, a LAN, between these servers. You are then able to add cluster features to your servers and achieving high availability through that. The second benefit is you are able to do the connection to your storage array with multipathing. In a normal local attached storage, in most cases, or usually, you're only having the single point of failure of the RAID controller. In this scenario, everything is redundant, and also the paths to the storage array are redundant. So if you're having a hardware error in this path, that's not a problem. The next benefit is you are able to do disaster-tolerant solutions through using technologies like mirroring or replication, synchronous or asynchronous. This gives you the availability you need for your applications, and you have the possibility to replicate a LAN, a volume, between two different storage arrays. So let's say if you're having two data centers, these features give you the possibility to be disaster tolerant. Another thing is storage features like online expansion. That's what I was talking about earlier when I said the expandability is limited if you're using local storage. If you're using centralized storage, it's no problem at all to add multiple disks and to increase the size of a single LAN, and therefore being able to increase the file system on your file servers that need the capacity. Then provisioning is another point. These centralized storage give you the availability to offer your service more space than you physically have. Of course, you have to monitor that carefully, but it gives you the possibility to reduce the amount of changes you have to do to your physical running environment. You just have to add disks as you need them. And the last but very important point is you are able to do central backup, restore, and recovery. So you can use storage features to do your backup and to do your restore. This is a very good feature because you're not relying on your client local area network. You keep these resources for what they are really planned for, to service your clients. Okay. When we're talking about storage area network, there are basically two different protocols or two different technologies that are used. The first one is fiber channel. Fiber channel provides a very high bandwidth, very low latency because we are talking about fiber optics, and there's very good features in offloading these encapsulation tasks that have to be done when transmitting SCSI packets across the network. With fiber channel, also long distances are possible. That's what I was talking about when I said you can achieve disaster recovery tolerance scenarios, and you can do long distance with fiber channel up to synchronous distances of 20, 30, 50 kilometers, depending on the hardware you're using. Another benefit of fiber channel is that you're completely separating the traffic from your storage network from the traffic of your host network, because it's two different technologies. There's no interruption if there are any problems at either side. The second technology used for storage area network is iSCSI. For iSCSI, there are similar components used as for your normal local area network. You're using network switches and you're using network cards and cables, copper-based cables. The administration is easy because the components are the same and your company normally has the local area network already in place. So the administration is easier, therefore. You could mix the storage, so the back end and the front end traffic, but you shouldn't do that, but it is technically possible. And things like multipassing software and the needed drivers to set up iSCSI are already included in Windows, so it's a cheaper way. In the future, or let's say now, upcoming is converged network. That's often referred to as fiber channel over Ethernet. There are new components introduced that give you the ability to do fiber channel over normal Ethernet. So you're you're merging two different technologies onto one physical layer, and therefore being able to use half of the hardware. This is considered to be the future of the SAN infrastructure. Right now, there are a lot of customers merging from their SAN infrastructure into these converged networks. We will see a lot of that in the future. Both is possible, optical or copper, for fiber channel Ethernet, depending on how far you want to go with this cable and with the signals. Sorry for that. Okay. talked about a lot about the storage features that give you the ability to do backup. In this case, I want to explain the snapshot features of a storage array. In this example, you're using a file on your server, and this file on your server is located on a LAN, on a disk. In this case, of course, when we're using a centralized storage, this is just a virtual LAN, so it's not really a physical disk, but it's just a small piece of a RAID group. If you're writing your file, of course, this file is written down to this LAN, which hosts a file system, and in this file system, all the changes are tracked. This file system and LAN is located on the centralized storage and is part of a RAID group. And in this RAID group, there's a volume where all the blocks of the file are located. If you're now doing a snapshot of this volume, then all changes that are done in the future from this point on are tracked by the storage array, and the original block is copied to this snapshot, to the copy out area. Only the blocks that are changed. So this gives you the combination of the RAID volume and the copy out area gives you the possibility to be able to go to the former version of your file, because you're able to roll back this snapshot and do all the reverse all the changes. A second possibility to do backup in a centralized storage array is to do a local copy clone. That means you're doing a full copy of your volume. Again, we are having the file on our server located on the file system in the LAN. This LAN is located on the storage array. And in this case, we're doing a clone of this volume, so full block copy of the LAN. And in the next step, we are able to map this clone to a different server. This may be a backup server, or this may be a different file server that is holding a copy of your original data. If now blocks or file contents are changed on the original volume, this does not affect the clone, because the clone is a backup of your original data. And if anything goes wrong with your original data, you can always go back to the snapshot on this side. The third feature I want to talk about is the remote copy, mirroring mode. That's the solution that gives you disaster recovery tolerant environment. Again, we have the example with the file on the server. In this case, we are writing the file to the storage array. The block is written to the primary SAN storage, and since it is a mirror, it is instantly copied to the secondary storage array, which is a different array. And these block changes are committed from the secondary storage to the primary storage, and if everything is right with these two storages, then the signal, the OK signal, is given back to the server. In this case, we changed the block, replicated it, and now having two different storages with exactly the same data. This gives us the possibility, if the primary storage fails, that we're still having a secondary storage that holds our data. So this is mostly used when having two different sites with two different several kilometers away from each other. Okay, if we're talking about SAN technologies, then we have to think about which components are used. And since it is still a disk array, of course, we're talking about different disk types that can be used within these centralized storages. We have the normal fiber channel 3.5-inch disks with different capacities. There's also 450 gigabytes available, and these are the most common disks when wanting to achieve performance while still having good capacity values. These are basically fiber channel disks, but fiber channel means it's a SAS disk with fiber channel interface. So if anyone is talking about fiber channel disks, then it's basically a SAS disk. These disks are very common and widely used, so it's not a new technology. We know that it's very reliant, and we know how these disks work. A lot of customers are already using them. These disks are mostly used in the RAID levels 10 or 5, but we see a lot of RAID 6 installation coming up today. If you're using RAID 10, you're having higher performance because there's no parity calculation, and if you're using RAID 5, you're obviously saving a lot of disks because you don't have to spend 50% in redundancy. The second disk type that is commonly widely used is the SATA disks. These disks are mainly for performance, for capacity, and these disks are SATA disks called nearline SAS disks because it's a SATA disk with a SAS interface. This gives you the ability in an eternal storage system, for example, to use both disk types, SATA and fiber channel, in the same disk enclosure. These disks are available with 1 terabyte, 2 terabytes now, and they are low cost and high capacity disks used if you're not having the need for a lot of performance, but you need disk space. Even if you're using hundreds of these disks, they still don't achieve good performance values. And of course, a very important point is, if you're using RAID 5 or RAID 6, then the RAID reconstruct on these disks is taking very, very long because they are slow and holding a lot of data. So disk types now and in the near future, we have 2.5-inch SAS SSDs. These disks are very, very fast because they're having an extremely low seek time, and there's no difference for these disks if it's random or sequential access because there's no head positioning in these disks. They are available in 100, 200, and 400 gigabytes. Just to give you an example of how fast they are, when talking about IOPS, we can replace 140 3.5-inch fiber channel disks with 6 solid-state disks. You have to take it into account that it's just by IOPS, because you still don't have the capacity of 140 disks, obviously. Because of the technology the SSDs are using, they are ideal for random massively parallel I/O, but with low capacity, and they are very expensive. Another disk type is the 2.5-inch SAS drives or fiber channel drives. They do save a lot of energy compared to the bigger versions of the SAS or fiber channel drives, while still achieving good performance values, about 70% of 3.5-inch disks, because the rounds per minute is lower. They are spinning slower. But you can use these disks where performance and capacity is needed, like the 3.5-inch versions. And of course, in a rack, you can put more of these disks into the same space that 3.5-inch disks would need. So you get more disks into a 19-inch rack. In the future, we will have SATA disks up to 3 terabytes, and also 2.5-inch disks with 1 terabyte. These disks are good for backup or archiving purposes, because you have a highly sequential workload on these disks, and yes, you need the space for that. as I said, where capacity counts. Okay, if you're talking about a centralized storage array, you of course have to talk about a single point of failures. In a local attached storage array, I said that before, is the single point of failure in the most cases the RAID controller where all the disks are attached to. In a centralized storage, everything is redundant. So in a centralized storage, you have the controller modules that are redundant. You have the front-end ports, fiber channel or iSCSI in this example, that are redundant, and also the connectivity to the back end. So the connectivity from the controller module to the disks is redundant. In this case, it's SAS-attached storage, not to the front-end hosts, not to your clients, but in the back end to the disks. And the RAID controllers in the disk shelves are redundant and, of course, are using RAID. So on the disk side, there's also no problem. And if you attach your front-end hosts redundantly, so two connections, one to each controller module, there's no single point of failure. There was a back-end connection in the past that was based on 4 gigabit fiber channel. The new storage arrays are using SAS in the back end. Now you can wonder why we are using SAS 6 gigabit instead of fiber channel 8 gigabits. That's because we're not using one lane of SAS for the backend, but we're using 4 lanes. So we don't have 4 gigabits per second, but 24 gigabits per second. So it's a lot faster than the fiber channel. Another, or if you do the math and calculate how many disks you can use on this back end, then we're talking about a constant write throughput of 12 megabytes per second for one disk, and in worst conditions. Of course, sequentially they can achieve more, but that's the basis on which we calculate. You can have up to 265 disks on one line of SAS. And the storage array can, of course, have 2, 3, 4 backend SAS connections. Another important point compared to fiber channel is that you can address a lot more disks with SAS than you could with fiber channel. Of course, we're not adding 16,000 drives to one SAS backend, but theoretically possible. Okay. Currently used host protocols, I already talked about the technology, is fiber channel. We're having some advantages of fiber channel compared to iSCSI, which will show up on the right side in a minute. Fiber channel uses optical components, and we're using cables of 2 lines with for incoming and outgoing traffic. The SCSI commands and the SCSI data is encapsulated in fiber channel frames, and that's it, and they are sent via the cable. This is a protocol that was built for block I/O, built for storage attachments, so there's very low latency in the protocol, and of course very low latency on the line because it's fiber optical based. And another point is the data encapsulation. There's not that much work to do when encapsulating a SCSI frame into a single fiber channel frame because there are no further layer between that. 3 examples for fiber channel cables. We have the SC connector, which is an older version, and the LC connector, which is currently the mainly used connection. We are using iSCSI. That's a technology that is based on standard Ethernet. So your local area network environment, as you know it from your clients, is used for iSCSI. You could route them, but you shouldn't. As I said before, you should do a separated network, dedicated Ethernet switches for your storage environment. And why is that? Because we can take advantage of 2 features that are not used for your clients, but that make sense for the back-end connectivity, which is jumbo frames and flow control. Jumbo frames make sense because the data is encapsulated in very small TCP frames. You can see that this in this picture down here. The SCSI command and the data is encapsulated into TCP, then into IP, and then is sent via Ethernet. That's because it's just a different protocol on the same network stack. Because of that, we have a relatively high latency with fiber channel, and because it's copper-based. The latency is added by TCP/IP because of the mechanism how TCP/IP works, because it's not designed for storage traffic in the first place. Okay, a little look into the future. We will have fiber channel with 16 gigabytes per second soon. Now it's 8 gigabits. We will also have iSCSI support on Ethernet that is faster than 10 gigabits per second. We are already working on that. And we will have the converged network adapters I talked about earlier that of course will support speeds of more than 10 gigabits as soon as Ethernet can support them. We have the traditional layout versus the converged layout. I talked about that earlier. The traditional layout with different technologies for the different purposes, InfiniBand, Ethernet, and fiber channel, all three different adapters. And with the converged network, we have the converged network switch, which talks all the protocols. Okay, now a little look at how all this works together. This is an example of the VMware stack with iSCSI. We have the separated front-end network on the left side and the separated back-end storage network on the right side. VMware uses what is called vSwitches, either distributed across multiple ESX servers or just locally. And one vSwitch for the front-end client access, that is just talking to this network, and a different vSwitch connected to the iSCSI local area network environment, where all the disks come in. iSCSI is also block-oriented, so we are handling disks and sharing them to the virtual machines. Several front-end LAN, right? The front-end LAN is different from the iSCSI LAN. I talked about that a minute ago, because we can't use jumbo frames in most cases, because all components in the past have to support jumbo frames, and your clients normally do not support that, and it's not needed normally. For iSCSI, there are several different things to consider. In the virtual environment, we use iSCSI for delivering the data stores that contain our virtual machines. We can also use iSCSI LANs to pass them through to the LAN if we don't want to use data stores. That's also possible. And possible but not recommended, you can also connect the iSCSI LAN and the front-end LAN and use so-called guest OS initiators to use a LAN that is located in the storage array directly into the VM. Okay, some screenshots to show you how all these components look like and how the administration works. That's the screenshot of the VMware vSphere client, so the VMware environment where you can see all the different data stores. In this case, they are based on iSCSI. That's basically the LANs mapped from the storage array to the VMware environment. And on this side, you have the network configuration with the VM kernel that is handling all the iSCSI stuff. The next screenshot shows the GUI of a Eternus DX system with a lot of hosts registered to the storage array with their WWN. The WWN is the fiber channel MAC address, if you want to say, if you want to call it that way. That's the address that identifies a single component in a fiber channel network. That's a screenshot that shows the administration GUI of a Brocade fiber channel HPA. That's a driver that has to be installed on your server. It shows you the adapter itself and the addresses the adapter has and what these adapters is zoned to and what LAN is visible on this controller. So also although these addresses look very confusing, it's very easy to configure all this together because you have a lot of insight in these networks. Now that we had a look at the server component and the storage component and the driver of the Brocade fiber channel HPA, we have to have a look at how all this is connected together. We talked about that we are using switches for these fiber channel networks, and this is a screenshot of the administration GUI of a Brocade fiber channel switch. You may notice that we're using alias, zones, and zone configuration, and you may wonder what all this is about. Alias is a name, in this case AMS1COA, that can be used to identify a worldwide name, a WWN. So to make it easier to identify single components, you can give it a name. Once you did that, you can do a so-called zone. That is basically what you know as VLAN from a network environment. It is basically just to tell the switch which component may talk to which component. So you have to make sure your servers can talk to the storage array, so you have to create zones to make this possible. All your zones are then added to a zone configuration. That's basically the configuration of all your switches. And with this done, you have made sure that the right components can talk to each other, but nothing else. Okay. We may now do some Q&A. And I then hand over to Kira, but yeah, I'm waiting for your questions.
Okay, thank you, Manuel. Ladies and gentlemen, your question and answer session will now begin. If you'd like to ask a question, please key star, then 1 on your telephone, record your name and press the hash key. If you decide to withdraw your question, simply key star 2. All questions will be answered in the order received, and you'll be advised when to ask your question, and all other lines remain on listen only. Alternatively, you can submit a question on the web by typing your question in the question and answer section on the screen and clicking on the Ask button. Just remind everybody, if you'd like to ask a question, please key star then 1 on your telephone, record your name and press the hash key, or via the web, type your question in the question and answer section on the screen and click on the Ask button. We have no questions coming through currently.
Okay, then I think thank you very much to all of you for your participation in today's call, and we are obviously distributing the slides you just saw today to the different participants. And well, I would like to invite you to have a look at what we are currently doing around the topic of SAN with below email address that you'll find in the presentation material, and get you some further insights into our Make IT Dynamic initiative, where SAN is one focused topic of. So once again, thank you very much for your participation, and I hope to see you again then in the upcoming calls in September timeframe around virtualization, backup, high availability. if there are no further questions, then I think
we're done.
We close this call and...
Okay, we have no further questions, so thank you, Manuel, and thank you, Kira. Ladies and gentlemen, that concludes your conference call for today. You may now disconnect. Thank you for joining and enjoy the rest of your day.
Thanks.